Hey everybody, welcome back. Today we're going to start back up with Chapter 2, Lesson 7. We only have 2 more lessons in Chapter 2, and I know it's going by so fast. But, okay, Chapter 2, Lesson 7. Today we're going to be solving equations with rational numbers. We have talked about everything already. As far as solving equations, how to solve equations, we have also talked about rational numbers. Operations between rational numbers. Now we get to combine them. It's going to be a big reunion with equations and rational numbers. So let's go. First 4 warm-ups. So begin, and please write these down. Simplest form for those fractions. So you can pause now and do them in simplest form. All right. So when you look at this, we can add, we need a common denominator first on the very first one. We already have that with tenths. Okay, so if I add straight across, I get 12 over 10. If I simplify that down, I can divide each of those by 2, take 6/5. If you rewrote that as a mixed number, that's fine. It would be 1 1/5. All right, next. Now we're subtracting on this one. So when I do that, again, I need a common denominator. So my common denominator, I have eighths and sixteenths. So what's my common denominator? Could be 16. Okay, so if I do that, I would get 2. Again, I have 2 3/8 minus 1 5/16. So I'm going to get 2, and I'm going to switch this into sixteenths. So I multiply by 2, and I get sixteenths. I get 6/16 for my equivalent fraction there of 3/8. Subtract up and down, and you get 6 minus 5 is 1/16, and 2 minus 1 is 1. So you will get 1 1/16 for your answer. Okay, there's your answer right there. Number 3, I'm going to move over right to the right here. I get number 3 is going to be 4.8 plus 3.6. Notice I put them both on top of each other. I lined up my decimals, and line up your decimals. Okay, and now I just add. 8 plus 6 is 14. Carry the 1. 1 plus 4 plus 3 is 8. My decimal goes here, and I'm done. 8.4. Last one. Same thing. Line up your decimals. So I get 2.4 minus 0.05, and I subtract. Okay, what goes in this spot? So I have a place value there. I get 0. So now, can I take 5 minus 0? No, you can't do that. So you got to borrow. Borrowing from the 4. 10 minus 5, 5. 3 minus 0, 3. Decimals, 2 minus 0, 2. 2.35 is your answer. All right, we're going to be doing a lot of this today, dealing with adding and subtracting fractions and decimals, both positive and negative. So get ready. We're going to have a combination of equations and rational numbers. I hope you're excited, because I am. Here we go. So we have m plus 4 equals 9. m plus 4 equals 9. How do you get things all by itself? Make sure that you solve. I almost rushed right into it. I was so excited. So solve these. Remember, we know how to solve equations. Okay? Opposite operations, inverse operations. So solve inverse operations and then answer the problem. So pause, try it. All right, so when we look at this, the very first thing I'm going to do, again, because you wrote all of these problems down, you're subtracting 4 here, inverse operations. It's what's happening to that 4. It's being added in the problem, which means I need to subtract to undo it. My answer is m equals 5. On the right side, m plus 5 equals a negative 6. Same idea here. Okay, I'm just going to subtract 5 on both sides. Okay, now I have a negative 6 minus 5. How do I answer that? Well, I add its opposite, and I have a negative 6 plus a negative 5. M is equal to negative 11. 11. Okay, m minus 7 equals negative 4. What do I do? Add 7. add 7, and I get m is equal to 3. Remember, when they are different signs, I subtract them. Different signs, subtract, I get 7 minus 4. Because 7 is farthest away from 0, that's how I get a positive 7. Or sorry, positive 3. Okay, next one, m minus 0.5 equals 8.25. You may be wondering, why did I use m the entire time? In case you were wondering, I like math. I really do. I know it's hard to believe, but I do like math. That's why I used m the entire time. Oh, Mr. Sheeman, look at those m's. M for math. All right, here we go. All right, so m minus 0.5 equals 8.25. Add 0.5 to both sides. Add 0.5. Make sure you line up your decimals here. Line them up. When you do, your answer, you bring down the 5, you bring down a 7, you bring down an 8. But don't forget about your decimal. 8.75 is your answer. Okay? Fantastic. Inverse operations. Now we're just, before we were given problems like these first two, okay, now we're going to start dealing with these next two right here, okay? Don't forget inverse operations the entire time, all right? Here we go. All right, now what I want you to do is I want you to think about these inverse operations of each other. Make sure you try to solve these. You don't have to write solve because you should already have written that down. Show your work for all of this. Pause now. Give it a shot. All right, here we go. 8.2p is equal to a negative 32.8. How do you get rid of that 8.2? By dividing by 8.2. Dividing by 8.2. Now, how do you divide by a decimal? Long division, right? So you take 8.2 divided by a 32.8. Okay? I don't like dividing by decimals. They're ugly. Okay, so get rid of it. Move that decimal over. Move my decimal over. My problem turns into 82 into 3328. Now, how many times does 82 go into 32? Doesn't go in there. How many times does 82 go into 328? Okay, let's try 4. 4 times 2 is 28. 4 times 8 is 32. Oh my goodness! Right off the bat, he gets it. So P is equal to 4. My answer is 4. All right? Oh, next, we have x over 1.2 equals 15. How do you get x all by itself? Yep, I hope you came up with multiplication. Multiplication, yes, you're going to multiply by 1.2. Okay, so now when you take 15 times 1.2, you multiply your 2 times by the 5, you get 0. 2 times 1 is 2, plus 1 is 3. 1, 5, 1. You get like this. Now, how many digits are behind the decimal point in the first number? 0. How many digits behind the decimal in the second number? 1. Add them together. 1. That means my answer has 1 digit behind the decimal, which is right here. So my answer is x equals 18. And you can do 18 or 18.0. That's completely up to you. But again, inverse operations for all of these problems. So think about what's happening in the problem, solve, and get rid of it. Okay? All right. Here we go. Next two inverse operations. Again, think of these, and I want you to pause and try these problems. Okay? We're going to quickly go through these. When you do a problem like this, m plus 9.1 equals 3. You subtract 9.1 from both sides. And when you do that, your answer very quickly is m equals a negative 6.1. Different signs means we need to subtract. And we get a negative because 9.1 is farther away from 0 than 3. Okay? 5.5 b is equal to 75.9. So when we do this problem, we have to divide 5.5 into 75.9. Now, explain to the person next to you. And if you don't have somebody sitting next to you, go find somebody. But I want you to explain to somebody why you divide here by 5.5. I'll even sit here and wait. All right, yeah, you tell them. Now, go back to them and give them a high five. I'll wait. All right, good. Okay, so now we divide because in the problem we are multiplying, right? So when we do this, we take 75.9 and we're going to divide 5.5 into it. So when we do that, make sure, again, move our decimals. We don't want to deal with dividing decimals. It's ugly. It's nasty. Don't do it. Okay? So now when we divide this into it, 55 goes into 75 once. When you subtract, you're left with 20 left over. Are we done? No! We bring down this 9. 55 into 209. How many times? 3 times, because 55 times 3 is 165. So now we subtract these two and we get 44. Okay? So now, am I done? No, we're not. Why am I not done? Because I have a remainder here. We are not going to have remainders, not in pre-algebra. Okay, so when we do this, we add our decimal, our 0, bring this down. Okay, and we have 55 into 440. My answer is 8, which is 440. Now am I done? Yep, yipper-doodles. So B is equal to 13.8. Okay, make sure that you're showing this work. This work is beautiful, it's glorious, it's wonderful. It just makes you smile at night. Okay, so showing your work on those problems. Now with these, again, opposite operation. So pause now, give these a shot. All right, very quickly, again, going through these, you subtract 2/7 on both sides, subtract 2/7 on both sides. When you take 3/7 minus 2/7, do you have common denominator? Yeah. So when we have a common denominator, -3 minus 2 is equal to a -5/7. Done with that one. Next one, another n. N minus 1/8 equals 5/16. Woo! How do we get rid of that 1/8? Add it to both sides. Why do I add it to both sides? Because you have to get rid of it. We get rid of it by inverse operations. That was your head talking, by the way. So as you do this, you add these two. Now, can I add 5/16 and 1/8? No, I can't. Why can't I? There's not common denominator. No, there's not common denominator. Thanks for telling me. Okay, so we need to find common denominator here. 16ths. Okay, here we go. 5/16 plus 2/16. My answer, 7/16. If you multiply them straight across, that is fine as well, but it would still break down to 7/16. All right? All right. All right, on this one, this is a problem that that you may not have seen before, but I want you to try it. Still, inverse operations of what's happening. So I want you to pause now, give this one a shot, and see how you do. All right, so when we look at this, what operation is happening between the 5/6 and the x? It's multiplication, right. So now what do we do to get rid of it? We have to divide. Divide by 5/6. So you have to take 5/8 divided by 5/6. Okay? Now, we have 5/8 divided by 5/6. How do we do a problem like this? Well, let's not divide straight across because I can't take 8 into 6. It'll be a decimal. We don't want to deal with that. So, what are the 3 words that you know about dividing fractions? Keep, flip, switch. I hope you have that memorized. So keep the first one. You're multiplying by the reciprocal. 5/8 times 6 over 5. Okay, we cancel out our 5s because I can simplify before I multiply. Cancel out the 5s because 5 divided by 5 is 1. Cancel out our 6 and our 8. Why? They have a common factor. What is it? 2. Divide each one by 2. You get 4, 3. Multiply straight across now. And our answer is going to be 3/4. Bam! 3/4 is our answer. What's our answer? X equals 3/4. Fantastic. The reason why we divide is because multiplication is happening inside the problem. Try one just like it. Okay, so pause, give this one a shot. Go! All right, now how do we do a problem like this? Well, we have to divide. Why do we divide? Because the problem is multiplying. Inverse operations, inverse operations. Raise your hand if you're sick of me saying inverse operations. I don't see any hands. All right, so that means I can just keep saying it. Okay, so when you do this, you divide because it's the inverse operations. Divide by 3/8. What does it mean to divide by fractions? You multiply by the reciprocal. By the reciprocal. Okay? Can I simplify before I multiply? Yep. What can I simplify? 6, 3. What do they simplify to? You got 2 and 1. All right? Now what do I do with this? Multiply straight across. Our answer, 2 times 8, 16. 19 times 1, 19. I get 16/19 as my answer. All right? Okay. Now, last problem of the day. This is anticipation. Or drum roll. Drum roll, drum roll, drum roll. Hey, here we go. Write this one down and I want you to try it. If you're not sure where to start, I want you to try something. Write it down and I want you to have something to try. All right? Just give me a little something. Okay? So pause now, give it a shot. All right, so it says, Tamara can mow 2/5 of an acre in 1 hour. If her yard is 2 acres, how many hours will it take her to mow the entire acre? So, think about what we know. We know she mows 2/5 of an acre every hour. Okay? Do we know how many hours she's mowing for? No. So what can we use? If we don't know how many hours that she's going to mow for, what can we use? Well, H for hours. Okay? Then, it says that her yard is 2 acres. So what's the distance of her yard? Her distance is 2 acres. We know that she's going 2 acres. However, we want to figure out how long it will take her to mow. So how can you figure out this equation? Well, if she goes 2/5 of an acre every hour, we have no idea how many hours. She needs to go 2 acres. We set up an equation. And the equation looks like this. 2/5 times x is equal to 2. Because we don't know how many hours, times h, because we're using h as hours. 2/5 times h is equal to 2. Because we don't know how many hours it's going to take her at the speed of 2/5 of an hour. 2 acres per hour. Okay? So, 2/5 of an acre. That means she mows so many acres. So how do we do this? Well, what operation is happening? Multiplication. What do we have to do? Divide. So I want you to try to, if you haven't answered this problem yet, I want you to give this one a shot right now. So pause, give it a shot. All right, so you're going to divide by 2/5 on each side. Divide by 2/5. And your answer is h equals 2 divided by 2/5. So 2 divided by 2/5 is the same thing as taking 2 times 5 over 2. Okay, and I put the 2 over 1 because it's cleaner for me to see. I can see that I have a denominator over that 2. Okay, can I simplify? Yep. How much? What can I simplify? I can simplify my 2's. Okay, so that tells me if I multiply straight across, I have my answer of 5. But what's my label? Well, it's hours. So it takes me about, it takes, not me, Tamara. I have that mode so much faster. But it takes Tamara 5 hours. That's a lot of mowing. A lot of mowing for 5 hours of mowing. A lot of work. Okay? So what's the answer? It is 5 hours. Make sure we come up with an equation. All right, I hope you enjoyed today. I hope you love this lesson. Awesome. I will see you tomorrow. Have a great day. Bye.